Next is the relation between angular velocity, frequency, and time period. You know, students, when the object is traveling along the one complete round, the angle traced by the particle is 360 degree, and you can write it as 2 pi. So the displacement becomes 2 pi. Put the value omega is equal to delta theta by delta t, and delta theta is 2 pi here, and divide by t. Now put the value of 1 by t. You know, omega is equal to 2 pi by t, and 1 by t is nu, so you can write it as 2 pi nu. The relation is angular velocity is equal to 2 pi times the angular frequency. Next is derive the relation between linear velocity and angular velocity. What is the relation between them? Linear velocity is the linear displacement traveled in a given time, and angular velocity is the angular displacement traveled in time t along a circular path. Now, what is the relation between these two values? Consider an object is initially at point A. After a small change in time, that is delta t, the object is at point B, that is moving along a circular path of radius r. Dear students, you know the relation of theta. The theta is equal to arc upon radius, that is delta s by r. Divide both sides with time. You have the relation delta theta by delta t into 1 by r into delta s by delta t. Now delta theta by delta t and delta s by delta t represent the average value of angular velocity on left hand side and linear velocity on right hand side. Now change this average value to the instantaneous value by applying the limit to the term. Here apply limit t tends to 0, and here also the limit t tends to 0. Now this average value is converted into instantaneous value, that is the angular velocity for a very small instant of time. You can write it as like this. Here put the value on left hand side as well as right hand side. You get this relation that omega, that is the angular velocity, is equal to linear velocity divided by r, or you can write it as v is equal to omega r. This is the relation between angular velocity and linear velocity. Further, we will study the angular acceleration and derive its relation with linear acceleration. The angular acceleration is denoted by alpha, and we can define it as the rate of change of angular velocity is known as angular acceleration. The angular velocity is omega, so rate of change of angular velocity is delta omega by delta t. Again, this is representing the average value of acceleration. So convert this average value to the instantaneous value. We can have put the limit delta t tends to 0 to delta omega by delta t, and the angular acceleration is now d omega by dt. And what is the SI unit? This angular velocity have radius per second and per second, so you can write it as radian per second square. And now find the relation between angular acceleration and linear acceleration. You know the relation between velocities. For the calculation of acceleration, velocity is required. So take this formula, v is equal to r omega, and now differentiate both sides. Here observe student, this is the product function, and what is the differentiation of a product function? This is written as like this: d by dt of product function, that is r is first function, omega is second function. I have told you one formula, that first function as it is, differentiation of second function plus second function as it is, and differentiation of first function with respect to the term which is given to you as variable. So we will apply this formula and we can write it as, here r is the first function as it is. Now differentiation of second function plus second function omega as it is, differentiation of first function. Now you know the differentiation of a constant is 0. Here the radius vector of the circular path is constant. That's why dr by dt is taken to be 0 and the second term becomes 0. So the value is only the first term, that is r into d omega by dt. So put it here, left hand side dv by dt, right hand side r into d omega by dt. Now you know dv by dt is the change in linear velocity with respect to time, that is linear acceleration, and d omega by dt is angular acceleration. So the relation is linear acceleration is equal to angular acceleration into r, and this is all about the uniform circular motion. In the next class we will calculate centripetal acceleration and centripetal force.